Hello students, I got a very good report from Ms. Clark from today. I am recording this on Monday night, so that's why I'm saying today, even though today when you see this is Tuesday. Sorry for the today confusion. Anyways, I got a good report and I hope to continue to get a good report from her as the week goes on. Ms. Clark suggested that I review this problem from the homework, and I thought that was a good, or the classwork, excuse me, and I thought that was a good idea. So I'm going to do that now. And so you'll remember I'm going to put 0 in for x. That's supposed to be like a dot, 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 dot. All right, so what do we got? We got x plus 2y equals 0. Put in 0 plus 2y equals 0. So I put in 0 for x right here. So that gives me 0 plus 2y equals 0. And 0 plus anything, if I'm adding 0, I'm adding nothing. So I just have the thing I started with. Okay, so let's see, 2 times y, remember this is like 2 times y equals 0. So the opposite of times is divide. I divide both sides by 2. These cancel out and I get y equals, how many 2's go into 0? Well, nothing goes into 0, so y equals 0. So if I put in 0 for x, I end up with, let me change the color, 0 for y. So now let's put in 0 for y and see what happens with x, right? X plus 2 times 0 equals 0. X plus, let's see, 2 times 0 is 0 equals 0. X plus 0 is just x equals 0. Oh man, I'm really confused here. So let's see, I put in a 0 for y, and what did I end up with? I ended up with a 0 for x. So you can see that I get the same point for both. I get the same point for both, and what does that mean? That means that my line passes through the origin. But some of you will understand what I'm about to say. There are an infinite amount of lines that pass through the origin. There's an infinite amount, meaning, well, you know what infinity means. It never ends. Look at all these lines. They all pass through the origin, right? Even this one. You know what? As a matter of fact, even this one that goes along the y-axis and even this one that goes along the x-axis, all of those lines pass through the origin. So how do I know which one to use? How do I know which one to use? I don't know which one to use. This is it's not a trick problem. It's just kind of a special problem. Okay, I don't know which one of those to use. That's why it's unique. I don't know which one to use. So what do I have to do? I have to come up with at least one other point. I have to come up with at least one other point because otherwise I don't know where this goes. It might go out this way. It might go out that way. It might go down this way. It might go down that way. I don't know. So I got to come up with at least one other point. So you know what? I'm going to pick an easy one. I'm going to put 1 in for y. Okay, and see what happens. I'm going to put 1 in for y and see what happens. Now, why did I pick 1? Well, no real reason. To be honest, no real reason. I just figured I'd try it. Let's see, x plus 2 times 1, that would be x plus 2 equals 0. Let's see, the opposite of plus. The opposite of plus is minus, so I minus 2 here. I minus 2 there. Those cancel out. 0 minus 2. 0 minus 2. Let's do this. All right, if I'm at 0, I have 0 minus 2. So if I'm at 0, there's me, little blue Eckert. If I'm at 0 and I subtract 2, does that mean I'm going in the positive direction or in the negative direction? It means I'm going in the negative direction. So I go 1, 2, and I end up right here. So 0 minus 2 equals negative 2. So if I put 1 in for y, I end up with negative 2 for x. So let's see, 1 for y, up 1, negative 2, 1, 2. Now I have another point on my line. Now I can draw a line. And all those other crazy lines that I drew, those no longer matter. This is the only one that matters. Let me make sure I have it more accurately done. This is the one that works because this is the line for this equation. And I say it again. Every line, every equation has a graph. This is the graph for this equation. Excellent, excellent, excellent. Okay, today we're going to be doing the same thing using x and y intercepts to graph. However, they're going to be much more challenging because now I'm going to start to throw in some fractions. But you could think back 2 or 3 weeks and think, hey, Mr. Eckert probably taught us fractions for some reason because we were going to be using them throughout the entire semester. So here we go. We're going to go ahead and find the x and y intercepts. Find x and y intercepts of this line. So what do I got to do? I got to put in a 0 for x. And I think you're going to notice something. Every time we put in 0, this stuff right here ends up being 0. And then it just ends up disappearing because 0 added or subtracted to anything just leaves what we already had. So that stuff is really just going to be gone. So what I'm just going to start doing is just checking that stuff out. And I end up with 2/3 times y equals 2. And so I ask myself, what's the opposite of times? And that's an easy question. The opposite of times is divide. So I divide this by 2/3, and I divide that by 2/3. And this checks out. So I get y equals 2 divided by 2/3. And why do I write it like that? Because I want to remind you that 2 divided by 2/3 is the same as saying how many 2/3 are there in 2. I just wanted to remind you of that. How many 2/3 are there in 2? I don't know. Let's see. Let's make 2. Let's divide it into thirds. And let's start to color them in. There's a 2/3 because it's 2 out of 3. So there's 1. Different color. There's a 2/3 because it's 2. It's 2 of a third. Remember, this is a third and this is a third. So a third and a third is 2/3. So there's 2. 1 and 1 is 2. And I think you see there's one more. How many 2/3 are in 2? There's 3. There's 3 2/3 inside of 2. There are 3 2/3 inside of 2. So if I put in 0 for x, I end up with 3 for y. If I put in 0 for x, I end up with 3 for y. And you ask yourself, why did we spend so much time doing all this silly fraction work? Why did we do that? Because of problems like this. Because when we get to problems like this, I need you, my students, to understand how to do it. So I put in a 0 for x. What do I got to do next? Simple. Put in a 0 for y. Oops. Let's get rid of that. Put the 0 in here. What's going to happen? Of course, those are going to check out. And I'm left with 1/2 x equals 2, which is the same as 1/2 times x equals 2. And the opposite of times, of course, is divide. Divide by 1/2. Divide by 1/2. Chiggity, check out. 2 divided by 1/2. So what am I going to do? I'm just going to erase some stuff here. Let's get rid of that. Let's get rid of that. Let's get rid of, you know what, let's just do this. This will save us some time. So what am I really asking? 2 divided by 1/2. I'm really asking how many 1/2s are in 2. 2 divided by 1/2. What I'm really asking is how many 1/2s are in 2. Well, here's a half. Here's a half. Here's a half. Here's a half. We can clearly see there's 4 of them. There's 4 of them. I don't have to remember any of that copy, switch, flip stuff. I just draw pictures. X equals 4. So when I put in 0 for y, I get 4 for x. I repeat, when I put in 0 for y, I get 4 for x. All right, dudes and dudettes, let's get rid of all this stuff. See ya. See ya. Because what do I need? I need my graph. Label my axes. There's my x, there's my y, and I plot my point. 0, 3. 0 means nowhere to the right, nowhere to the left. 3 is positive. 1, 2, 3. Excuse me. 4, 0. 4 means to the right 4. 1, 2, 3, 4. 0 means not up any, not down any. That's right here. Every equation has a graph. Every equation has a graph. And this equation right here belongs to that graph. We rule. That's awesome. Here's what I need you to do. I need you to do a great job with fractions today. I need you to be nice to Ms. Clark and tell her thank you for subbing for you. I need you to be good people. Do a great job today. I'm proud of you. Thank you very much.